Welcome back. This is day 8 of Ecology, and today we're going to be talking about how does an ecosystem develop. But before we get to that, you guys have got 2 do not questions, so go ahead and pause this video, answer questions 1 and 2, and press play when you're ready to review them. All right, number 1, this is an ecosystem. There are many organisms of different species in this location interacting with the air, the water, and the land components of this environment. Select the correct energy flow of energy in this ecosystem from the choices below. Well, to answer this question, let's draw ourselves a handy-dandy energy pyramid. Now, what organism do we always find on the bottom of this energy pyramid? Well, we always find our producers there. And why do we find our producers there? Well, we find our producers there because they're able to undergo that special process called photosynthesis that allows them to take the energy from the sun and convert it into chemical energy that other animals can then use. So then consumers are going to come along and eat those plants. But then what happens after the consumers die? Like, let's take this rabbit, for example. What's going to happen when this rabbit dies? Well, his body's going to get broken down, and our special friends called decomposers are going to recycle those nutrients back into the environment so they can be used again. So what is the correct answer choice here? Well, it should be answer choice 3, where the sun gives its energy to producers, producers pass the energy to consumers, and then consumers to decomposers. All right, number 2, describe at least one human impact that could have a negative effect on the ecosystem above, and explain why this human activity would harm the producers, the consumers, and the decomposers in the ecosystem above. So you could have said multiple things for this answer, or for this question rather. I gave you 2 examples. So I said deforestation, right? If we remove these trees from the ecosystem, it will decrease the number of producers and thus the amount of energy entering this ecosystem. You could have also said overhunting, because if humans come through and kill all of the animals in this area, what's going to happen? Well, removing consumers from this ecosystem will impact other trophic levels as well as as multiple species are intertwined through a food web. Remember that our impact on one species is going to impact other species in the same area who depend or rely on that species for food, because of the way that all of these organisms are connected through food web. Right. Now let's get started with today's lesson. So the first thing we're actually going to do is watch a short video about the eruption of Mount St. Helens, which is a volcano. So I'm going to read through this passage, and I'm going to have you guys go watch the video that is linked on your worksheet. Okay, it's only about 3 minutes, and I promise it's actually pretty interesting. So on May 18th, 1980, that was just a few days ago. I was going to say if today was May 18th, that'd be really crazy, but okay. On May 18th, 1980, Mount St. Helens, a stratovolcano located in Washington state, erupted after a series of earthquakes. It is the only major volcanic eruption to occur in the United States since 1915. The 1980 eruption of Mount St. Helens claimed the lives of 57 people and millions of animals while causing approximately $3 billion in damages. So now, as you watch this video on the volcanic eruption of Mount St. Helens, I want you to think, after seeing this monstrosity, how could life return to this area impacted by this natural disaster? Okay, so right now, pause this video, go watch the video that's linked on your worksheet. It's actually showing you the aftermath of this volcanic eruption, and then come back when you're ready. All right. So this is a picture that I've included that shows you the before and after pictures of this volcanic eruption. Right? Before, we see lots of trees, we see lots of life in the area, and then afterwards it's just death, right? We don't see any sign of life, we just see rocks. So how does life return to an area like this? Well, it's going to return through a process known as ecological succession. So let's talk about what that means. Well, what is ecological succession? This is the natural or gradual changes in the types of species that live in an area, and more specifically, the gradual replacement of one plant community by another through natural processes over time. So after that volcanic eruption, all that was left in an area was just bare rock. There wasn't even any soil in the area. But gradually over time, through the help of pioneer species, which we'll talk about in just a few seconds, life started to come back to the area, right? And this process is known as ecological succession, where gradually over several years, different species start to come back and life starts to return to an area. And we're going to walk through what each of these stages looks like. Okay. So there's actually two types of ecological succession. The first is primary succession. Now, this is the process of creating life in an area where no life or soil previously existed. You're basically starting from scratch. Right? There is no life, there is no soil. You are starting from ground zero and building up. But with secondary succession, this is the process of rebuilding a previously existing community after being destroyed. I'm not sure why I'm writing in black. Why did I do that? This is the process of rebuilding a previously existing community after being destroyed by some disaster like fire. But the reason that we're not starting from scratch here is because soil exists. Okay, so there's already a little bit of life still remaining in the area. So we're not starting from scratch, we're just rebuilding with secondary succession. All right, so let's take a picture, or a look at two examples of each of these processes. So this picture right here, would this be an example of primary or secondary succession? Well, this is going to be an example of secondary succession because we see that after this fire, although it destroyed a lot of life in the area, there is still soil remaining, which is kind of the first step to rebuilding life. Okay, we need soil because most plants need soil to grow. So with secondary succession, we're not starting from scratch, we're just rebuilding what was already there. Okay, but what is this an example of? All I see at the beginning here are exposed rocks, and I don't see any mention of soil. So this is going to be an example of primary succession. We are again starting from scratch. All we've got are rocks, okay? And we have to actually create soil and then eventually new species, or not creating new species, but new species will come into the area thanks to the help of some pioneer species called lichens and mosses, which we'll talk about on the next slide. Right, so primary succession, let's look at what that looks like. So primary succession begins in a place without any soil. Again, primary succession, you are starting from scratch. There is no life in that area. Okay, and so some examples of where primary succession could happen are the sides of volcanoes, much like our Mount St. Helens example, as well as landslides and flooding. There is no life, no remaining life in the area. Okay. And the first thing that has to happen with primary succession is lichens that do not actually need soil to grow on rocks. And lichens are these really cool organisms. So it's actually two organisms that are in a symbiotic relationship with each other. So it's a fungi and that's, you might have seen these if you've ever been hiking. They grow on rocks. Oh no, I'm unstable. All right, I was saying you might have seen lichens before if you've ever been out hiking. They grow on rocks, they grow on trees. They don't require much to grow and survive. And that's why this is the first organism that really comes out in ecological succession, because again, they don't need soil. They need pretty minimal, they're minimalists, if you will. But then the next thing that happens is these lichens actually produce soil, which is really, really cool. They actually release acids that start to break down rocks and form soil over time. And then as they start to do that, our next pioneer species that comes in is known as mosses. And again, you may have seen mosses out before if you've been hiking or if you've been upstate. And these green things right here are mosses. And you can actually see that they're hanging out next to our lichens. So these are the first species to appear in an area that is starting from scratch. And we call these pioneer species because pioneers are kind of the first to appear. We're the first to explore an area. So these two species are the first to arrive in an area, lichens and mosses, because again, we've got to start forming that soil and making this a place where life can prevail. Right? And here is another picture of what that looks like. So again, lichens are going to break down that rock with the acids that they secrete to form soil. And then as they do that, mosses are going to start to come in. And mosses are really helpful because they can trap moisture and prevent soil erosion. So preventing soil erosion means that soil is going to stay in that area, which again will make it a more helpful environment for plants to start to grow over time. Great, but now let's talk about secondary succession. So again, secondary succession begins in a place that already has soil and was once the home of living organisms. So this occurs faster because again, you're not starting from scratch. You've already got some soil there to work with. And there's actually different pioneer species here than with primary succession. So because we already have soil, we don't really need the help of lichens and moss quite as much. So in here, in this example of secondary succession, you can see that we go ahead and hop right into annual plants, right? Some small grasses have started to form because, again, we already have soil, which means that plants can grow. So secondary occurs a little bit faster because, again, you already have soil, right? Oh, and here's an example. Secondary succession occurs after forest fires, right? So even though this fire is going to wipe out most life in the area, we still have soil, which allows that life to start to grow. Right, now, on these pictures, we see that the end result of ecological succession is something called a climax community. Well, what is a climax community? Well, climax communities are kind of the end goal of ecological succession. This is going to be a stable group of plants and animals that is the end result of the ecological succession process. So climax community is going to be the last step of this ecological succession, where we've got lots of different plants and animals living together in an area. So this is the end goal. But this does not always mean big trees. Like, this is probably the first thing you think of when you think of a climax community. Lots of big trees and grasses and bushes, but that's not always the case. It's going to depend on the environment and the ecosystem that we're in. So for example, a climax community could just be a series of grasses and prairies, or cacti and deserts, right? This is very much a climax community, just as this over here is. So both are examples of big groups of plants and animals that are living in harmony and create a stable ecosystem. Right? But I do want to point out that this process of ecological succession takes a long, long time to happen. So the average time it takes to reach a climax community is actually 150 years. So this takes a long, long time. And so I actually wanted to show you, it's been about 40 years, 41 actually, since the Mount St. Helens eruption. And I wanted to show you where we're at in that, in this line of ecological succession. So we're gonna be around in this area right here. But this is a picture that someone actually took around last week of what Mount St. Helens actually looks like today. So although we have not yet reached that climax community, you can see that life has started to return. And again, we're somewhere in the middle of this area of growth where weeds and grasses and flowers have started to grow, but we have not yet reached that climax community. But in just a few years' time, about 100 more, we'll get there. But this is just kind of a nice reminder that life will return to an area. It just takes some time. All right, guys, that is all I've got for you today. So make sure you complete your exit ticket. Let me know if you have any questions, and have a wonderful afternoon. I'll see you guys tomorrow.